If a once-a-week pill could extend your life by 7+ years, would you take it? The drug rapamycin was discovered in the soil of Easter Island in the 1960s. According to one researcher, the overwhelming evidence suggests that rapamycin is a universal anti-aging drug. That is, it extends lifespan in all tested models from yeast to mammals, suppresses cell senescence, aging, and delays the onset of age-related diseases. Rapamycin, an inhibitor of mechanistic target of rapamycin, mTOR, has the strongest experimental support to date as a potential anti-aging therapeutic in mammals. Unlike many other compounds that have been claimed to influence longevity, rapamycin has been repeatedly tested in long-lived, genetically heterogeneous mice, in which it extends both mean and maximum lifespans. It has been demonstrated that rapamycin has a robust effect on the lifespan of mice. The current mouse data conclusively demonstrate that rapamycin is effective in preventing, reversing a broad range of age-related conditions, including lifespan with minimal adverse effects or toxicity. However, there is always a concern as to how well discoveries in mice translate to humans. Rapamycin is approved by the FDA for use in humans for transplantation and pancreatic cancer, and has been used safely for decades. According to some, no real side effects preclude their use as anti-aging drugs today. Since 1999, rapamycin has been used by millions of patients with no unexpected problems. It may be, however, that rapamycin is safe enough for very sick patients, not for healthy people. In some tests, though, healthy elderly people treated with rapamycin or other mTOR inhibitors showed no ill effects. When rapamycin was shown to increase the lifespan of mice, one of the first questions raised was whether this increase was due to rapamycin's effect on aging. One of the ways to approach this question is to determine if rapamycin has a broad effect on processes directly related to aging, e.g., the incidence of diseases. In other words, does rapamycin delay age-related diseases as well as increase lifespan? The data show that in mice rapamycin has a major impact on cancer, cardiac diseases and function, and normal brain aging, including brain vascular aging and neurodegenerative-like processes in neurodegenerative diseases. In addition, rapamycin attenuates cell senescence in a broad range of cell types. Thus, rapamycin appears to have an anti-aging impact on a large number of disease-related processes in mice. Consequently, rapamycin is the first drug shown to have anti-aging actions in a mammal. One of the intriguing aspects of rapamycin's actions is that it is effective when given in later life. Interestingly, the current data show that rapamycin is as effective in increasing lifespan late in life as when it is given earlier in life. These data are exciting because it suggests that rapamycin can reverse many of the adverse aspects of aging late in life. Working independently, clinical researchers have studied rapamycin for the prevention and treatment of nearly every age-related disease, including cancer, obesity, atherosclerosis, and neurodegeneration. If a drug is indicated for all age-related diseases, it must be an anti-aging drug in that it targets a common driver of age-related diseases. Although rapamycin may reverse some manifestations of aging, it is more effective at slowing down aging than reversing it. Therefore, rapamycin will be most effective when administered at the pre-disease stages of age-related diseases. For example, it has been suggested that mTOR inhibitors could be useful in Alzheimer's disease, but only in the earliest stages. In addition, rapamycin is more effective for preventing cancer than treating it. It may also be useful for treating osteoporosis, though not a broken hip after an osteoporotic fracture. Rapamycin may slow atherosclerosis, thereby preventing myocardial infarction, but is unlikely to help reverse an infarction. In other words, anti-aging drugs extend the health span and are most effective before overt diseases cause organ damage and loss of function. So, is it too late to take rapamycin once aging reaches an unhealthy stage? According to some, it is not too late. Even if one or a few age-related diseases renders aging unhealthy, other potential diseases are still at pre-disease stages, and anti-aging drugs may delay their development, and they may slow down further progression of existing overt diseases. When taken late in life, rapamycin increases lifespan by 9–14% in studies with mice. This possibly equates to more than 7 years of human life. While the data is promising, human studies to date have been limited. Ultimately, the choice is up to you.